So, good morning, everybody. Thanks for having me here today. Before we start with the presentation, I'd like to start with a short funny story. Just 2 weeks ago, I had 52 Badger Kutchers in the final presentations here at the university. So it was more than 10,000 seconds of presentation time. So it seems that I'm kind of experienced from the audience side related to Badger Kutcher presentations, but I myself, I gave the last Badger Kutcher, I think it was 10 years ago. So it was really challenging to prepare this for today, but it was nice work and fun to do it. So let's jump into the presentation and please switch to the real presentation then. Before I get into the topic, I'd like to give you a short overview of our lab equipment and test environment to show you how we work. We have a movement-based driving simulator, we use different seating boxes, we conduct tests in mixed reality, and also have instrumented vehicles to be used on our outdoor test track. But now I'd like to talk about automated driving, and I would like to clear up some ambiguities. The first assumption that is wrong is that vehicle automation is only binary. This is not the case. There is not only manual and automated vehicles, but there are some levels of distinction in between. I will discuss this further on. On the one side, users are excited about the technology. They fantasize on how this could change the mobility. Public media communicates that you can read a book or even sleep in the car. But the concrete capabilities and limitations of an automated vehicle are typically unknown to the driver or not being questioned. And to give an example, when we use driving assistance systems, then drivers have learned to override annoying safety mechanisms, like placing a fruit on the steering wheel to mimic that they're holding it with their hands. And this way they can do side activities or even sleep, although they are not allowed to do so. More problematic is that they expose themselves to danger without being aware of it. And a good example here is Tesla. According to the user manual, which you see on the right, the driver has to be prepared to take corrective actions all the time when using the system. But most drivers do not read the handbook. They are not aware of the limitations or they ignore them. I will talk about this later in more details. At this stage, we still don't know anything about the different automation levels. According to the Society of Automotive Engineers, there are 6 levels, ranging from 0, which is manual driving, up to 5, which is fully automated driving. Each level has different capabilities, and the Tesla Autopilot, for example, is a system at level 2. But this does not mean that Model X, for example, is a level 2 vehicle. A specific vehicle might have different systems at different levels, like adaptive cruise control on level 1 and highway overtaking assistant at level 3, or an automated valet parking system at level 5 automation. For a specific system, further restrictions apply according to the so-called operational design domain. This means that the highway assistant at level 3 might only work on highway A9 from Munich to Nuremberg between 9 a.m. and 4 p.m. only in dry weather conditions and when lane markings are present. Since a vehicle is not equipped with just one automation technology at a specific level and the operation range is further limited, it's very hard to assess for a driver if an automated system is actually in operation and if it's working properly. This might lead to confusion, and we see here an example that makes this clear. A Tesla hits a stationary van with autopilot activated. The reason is that the system is outside the defined operating range as communicated via the handbook, for example, but the driver, first, he did not read the handbook, and second, he never had experienced such a situation before, and therefore he trusted the system, he trusted the vehicle. And this is also supported by the statement which he gave later: yes, I could have reacted sooner, but when the car did it correctly 1,000 times before, I assume that it will do so also next time. So it's really important to communicate the system behavior in a transparent way to the driver. This connects to another problem, the responsibility. Responsibility is typically also not known and has led to severe accidents in the past. A prominent one is here this Tesla accident, where a Tesla car crashed into a truck at the location marked with a cross here. Both driver and autopilot systems did not see the truck, but the driver ignored his responsibility. According to the level 2 automation definition, he should have been all the time and ready to take corrective actions, but he wasn't. In the actual case, the drive was 37 minutes long and he grasped the steering wheel only 25 seconds, and he also ignored numerous warnings. So we see that responsibility is a big issue in automated driving. And it is more than just, am I responsible or are you responsible, the system? In fact, there are different levels of responsibilities, for example, to monitor the traffic and identifying obstacles, to take longitudinal or lateral vehicle control, or to have the responsibility or being held liable in case of an accident. And for the later point, there are several groups that could be held liable, as this slide communicates. It could be the engineer, the driver, it could be the manufacturer or the authority. The fact that this responsibility is not fully regulated in Germany, at least, is one of the reasons why manufacturers just have stepped back to deploy the automated driving functions to the car. And another problem arises from the wrong use of the term autonomous driving. Of course, systems are automated, they are pre-programmed, and they might take decisions based on AI technology, but they are not autonomous, because autonomous means self-determination or freedom of decision or action, which is not the case. Think about this example. You call your autonomous vehicle to take you to a performance at the opera in Munich. If it could act autonomously, it might reply, no, I'd rather go to the drive-in cinema so I can get something out of it too. So it's not autonomous, and this brings me already to my final slide. For success of automated driving, it is necessary to build technology that supports the individual user, showing who is responsible, communicating system capabilities and boundaries, adapting to drivers' needs and expertise, so in the end, to prevent incorrect use and maintain driving safety. With this, I'm done with my Bayern20x20 presentation. I'm open for any questions that might arise, and thank you for your attention.